welcome to this lecture. So in the previous lecture we have completed this very long function that was check enemy X collision. Now it's time to complete this check enemy Y collision. So it basically checks for the enemy collision in the Y axis. So as before, we'll just make here collider, and that should be initialized as sprite collide any and check for the enemy. And similarly self dot we have ground step pipe ground, similar as that of before. So after this collider we have something that is in this case of Y. We can have with this enemy we can have a bricks. So in the case of X there can be an collider, that is pipe, and there can be this enemy, another enemy group. But in the case of Y there won't be any another enemy group, rather there can be the brick. So there can be the collision with the bricks. So to check that, just create this sprite collide any and just put here enemy, and the group would be brick group. Just put a brick group. So now we have something that is a two collider here with the step pipe and with the bricks. Now check for this collider, and if it is true, basically it is returning us a boolean if there is a collision between enemy and the pipe. And if it is true, then what are you gonna do? That is, we have checked for the collider, and after that we'll just check for the bottom first and just to less sign here. So it should be enemy, and just get this rect bottom, that is the bottom for that enemy bottom components. And if it is greater than collider dot rect dot bottom, that means if the weight of our enemy is greater than that of our pipe. So what are you gonna do? So there should be the huge increment in our enemy Y velocity, that is with 7. And similarly, now it's time to make our enemy to fall, because we have now collision with the pipe and it should now fall. So that means we have to make the state falling. So before that, I'll just make here a quick change, that is enemy rect top now should be bottom, because it should now fall. So that means it should be collider dot rect bottom. And after that we'll just make our state, that is game state, just call here enemy and state to be c dot fall. So now our enemy is basically falling. Now it's time to check if the weight, basically if the collider rect bottom is greater than that of this enemy rect bottom. So that should be in elif. I'll just take all of these statement and just paste it out here. Instead of greater, I'll say it is smaller. And if it is smaller, what you're gonna do is just make this enemy velocity to be static. So that should be not self, it should be enemy, and this get this Y velocity should be now static, that means just make it O. And now it should just move at the top between these sprite, that means just make this bottom of rect to be collider rect and make it top. And now basically enemy should be in the state to walk, that means enemy dot state should be now c dot walk. So it just should walk in that brick, maybe in that pipe, basically in that pipe that enemy should just walk. So next is the collision between our enemy and the bricks. That means we'll check if brick, that means if there is a collision between the brick and the enemy, that means this brick will be true if there is any collision, and this will run. So if it is true, so what you're gonna do here is we'll just check. So instead of if, I'll just put here elif, and we'll just check here, that is brick state. So if the brick state is, we have something that is bombed, and we have created this bumped. In that case, this should be brick dot state. And this bumped was basically, we worked with this bumping function in the creation of the brick class. So you can just take a reference from that brick class and check what this bumped is really about. So first we'll just say this enemy should be killed based on that criteria that we created in this kill function, that is of enemy. And now it's time to do something, that is just call another function, and that should be something like so we won't be calling, instead we just will be implementing in this same code. So let me just implement in here instead of just calling another function, and that would be just get this sprite about to die group and just add it, that is our enemy. So enemy is going to die. So we'll check now for the Mario Center EX. So let me say Mario rect, and if you just talk about this rectangle, there should be top, bottom, left, right, and center X. So we are just dealing now with the center X. So if it is greater than that of bricks, so let me say if it is greater than that of brick, rect, and center X, then what you're gonna do is we'll just make basically an statement or an action in order to just start a death jump here. So that should be enemy dot start death jump. So in this start death jump, you just put right your action, that is right action. Similarly, we just have now death action, that is you can just implement it in here, that is in else part, and just let me put it all of this code here, and just instead of right we should have their left. So basically it is when the Mario just set this brick containing our enemy. So if this enemy is within these bricks, and if we just hit that bricks, and there should be the start death jump, and start death jump is basically function of this enemy in order to make our enemy kill. So next thing what you can do here is maybe outside this, if this brick state is bumped, now we'll say that is elif what this enemy rect. Now what this enemy rect x is greater than that of brick rect x. What this width of our enemy is greater than that of rect. So that means we have to now implement another code, that means enemy y velocity should be increased. So it shouldn't be killed, rather its velocity should be increased, because the weight here of the rect of our enemy, that is basically weight of our enemy, is greater than that of bricks. That means there should not be any effect for our enemy, rather there should be only effect for our bricks. So that means now it's time to make our enemy rect bottom, and it should be rect bottom. Now because it is of heavy weight, now it should be assigned this bricks and rect top of this brick. And next thing what you're gonna do is now enemy after this rect top, and there should be the destroyment of our breeze. So when you assign this enemy rect at this bottom component to this brick top component, then bricks should vanish and this enemy should be state. So now enemy state should be about to fall, so that means it should be in fall state. So let's call that else. So this should be else part, that means if it is maybe less than, then what you can do is we'll just make this enemy velocity to be static, and let me just make first that is static means there should be O here, and enemy now should be in the walking position. So in order to make enemy state as walk, we have to now create this enemy and rect bottom here. So this enemy rect bottom now should be assigned as in brick rect top as before, instead of here in this, because we are just falling, so falling cannot be from bottom to top. So this falling, let me just type here top first, and in this case there should not be falling from bottom to top, it should be top here, because enemy is in the falling state. That means it should fall from top to bottom here. So in order to make fall, this is the criteria. And now in order to make walk, we should make this velocity as 0, and now make the enemy status or enemy state as c.walk. So now we have implemented this method, that is important method. If you see here, this is for check enemy y collisions. Now it's time to make some two important method maybe, and that is check Mario x collision, check Mario y collision. So if you wonder where we have this adjust Mario position, that is implemented here right at the beginning. So we now have to only implement this check Mario x collision and check Mario y collision in order to get our complete Mario game for level 1. So that will be implemented in the upcoming lectures. See you in the next.